Today we're going to look at systems of linear inequalities. So far we have been working with systems of linear equations. Now we're going to put yesterday's lesson together and do a system of linear inequalities. So the first thing we're going to talk about is, what is it? A linear system of linear inequalities is two or more inequalities that have the same variables, and those inequalities work together. The solution is part of the half plane. Remember, the half plane is the part that we shaded yesterday. The solution is part of the half plane that overlaps. This solution will make both inequalities true. Okay? So what we're looking for is, remember, in a system of equations, we got like an ordered pair, or we said no solution, or infinitely many. In a system of linear inequalities, there is one method, and that is graphing, and the solution is the part of the graph that the shaded regions overlap. So how do we do this process? Well, the first thing you're going to do is you're going to graph the first inequality. You're going to find the slope, the y-intercept. You have to figure out dotted or solid, and then your shading. Then you're going to go to the second inequality. You find the slope, the y-intercept, dotted or solid, and then your shading. And where the shadings overlap, that is your solution, meaning any ordered pair in that overlapped region would make both inequalities true. All right, so on this first one, it says determine if the ordered pair is a solution to the system of linear inequalities. So remember, this is our x, this is our y, so we would simply plug it in. So we would say three is less than 1/2 times -8 plus 2. Well, half of -8 is -4. -4 plus 2 is -2. Is 3 less than -2? And that is no. So since one of those fails, this is not a solution. Okay? Now, if both of them are correct, both of them work, then it is a solution. Okay, let's try the second one. So remember, again, this is my x, this is my y. So it'd be 2 times -10 minus -11. And is that less than -5? And then we'd work that out and we'd get -20. That turns to plus 11, less than -5. That gives me a -9, less than -5. That is true. Okay, so now we try the next one. 3 times -10 minus -11. And we want to know, is that greater than 8? So that's -30 plus 11, which gives me -19, greater than 8. That is false. That's a no. So this is not a solution. Okay? So that's how we test them. We just plug them in for x and y and see if it works. Remember, it has to work in both inequalities to be a solution. All right, so now we're going to start into the graphing part. So I'm going to start with the first equation. My slope is 1/2. My y-intercept is 2, and that one is going to be a dotted line. So I come over here, I go to 2, then I go up 1, right 2, up 1, right 2. It's a dotted line, so I make my line dotted. And then it says y is less than that, so that would shade below that line. Then I'm going to come back, and now I'm going to graph the second one. So my slope on the second one is -2, my y-intercept is -3, and that one is a solid line. So I come down 1, 2, 3, I put my dot, I go up to left 1, up to left 1. This one is a solid line. And then this one says y is greater than that, which would be all of this, the above one. So my solution would be all of this space here where those two shadings overlap. So if I picked an ordered pair from that, let's say 0, 0, and plugged it into both of them, 0 is less than 2, you bet. And 0 is greater than -3. You bet. So a solution, any ordered pair from this shaded region, would make both inequalities true. All right, let's try the next one then. So on this next one, we'll start with the first one. Remember, that is going to be a horizontal line. So I come up here to 3. I connect that clear across. It's a solid line. And it says y is less than that, so it would shade below. My second one here is going to be, my slope is 1, my y-intercept is 4, and that is a dotted line. So I come up 1, 2, 3, 4, and I have a slope of 1. It's a dotted line. And it says y is less than that, so it would shade all of this area. So my solution would be everything here, where the shading is overlapping. And we'll just color that in. And there would be my solution to that one. Okay, let's try this third one. So on this third one, we'll start off with the top one. And my slope is 2, my y-intercept is -5, and it's a dotted line. So I come down 1, 2, 3, 4, 5. I go up to right 1, up to right 1. It's a dotted line. And it says y is less than that, so I'm going to shade all of the bottom. My second equation is going to be a slope of 4, a y-intercept of -6, and that also is a dotted line. So I come down here to -6. From there I go 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1. It's going to be this line here. And this one, y is greater than, it's going to be this side. So my solution would be this little sliver of the graph down in the bottom corner. Okay, now like I said, any ordered pair in that solution, in that shaded region that's overlapped, would satisfy both inequalities. And that's how we do a system of linear inequalities.